So I'm Cassidy Fisher-Wellman, and we are Group 2 Translation, and I'm going to be talking about initiation complex. Okay, so for initiation, the first thing is the 30S subunit is going to come in and bind at the AUG site with your P site. The 16S subunit of the 30S will bind to the Shi-Delgarno sequence, which is an AG-rich sequence upstream of the AUG. This will help selectively bind to this AUG site. At that point, we will have IF1 bind to, or F1 on the A site, which helps IF2 and IF3 bind. IF3 is going to be on the P site, and that helps the 50S subunit from coming in too soon, and also helps recruit the Fmet tRNA from all other charged tRNAs in the system. Fmet tRNA will come in with IF2 bound to the GTP on Fmet. It will bind to the AUG sequence. At this point, the 50S subunit will come in and the GTP on IF2 will be hydrolyzed, which will release IF2, IF1, and IF3 from the ribosome. And initiation is complete, and we will move on to elongation.
Hi, I'm Kanjana Lasandisu, and I'm going to talk about the elongation of prokaryotic translation. And for the first step of elongation, the tRNA charged with the amino acid lysine come to the A site with help of elongation factor TU bound with GTP. And after GTP hydrolysis, elongation factor is released, so anticodon of the tRNA pair with the codon of mRNA in the A site. And the second step, peptide bond is formed between Fmet and lysine by peptidyl-transferase. And Fmet leaves the first tRNA, so there are dipeptidyl tRNA in the A site and uncharged tRNA in the P site.
Hello, I'm Long. I'm going to be talking about the third step of elongation.
1.
Here we have the third step of elongation. This step is also called translocation. It begins with the ribosome moving one codon in the 3' direction. This part requires elongation factor G and GTP for hydrolysis. The dipeptidyl tRNA moves from A site to P site, while the deacylated tRNA moves from P site to E site. Afterwards, a new peptidyl tRNA moves into the A site. The deacylated tRNA exits the E sites, and this process continues until the ribosome reaches the tryptophan-rich sequence.
Hi, I'm Austin Vanderford, and I will be going over attenuation of prokaryotic translation. When concentrations of tryptophan are low, the ribosome stalls at the 2 tryptophan codons in the leader peptide. Sequence 2 and 3 are free to pair with each other, and transcription continues. When concentrations of tryptophan are high, the ribosome quickly translates the leader and blocks the sequence, and blocks sequence 2 before sequence 3 is transcribed. Sequences 3 and 4 pair, and translation attenuates.